Tonight is April the 19th, 2019. I'm going to document something just for posterity, probably more than anything else. Is one of these Boonton electronic Sonora Voltmeter. It's a model 91CA. I see these things on eBay for sale. They usually want about 40 to 50 bucks for them, and probably about that much shipping. And every one that I've seen out there recently does not have the probe. Well, if you don't have a probe, it's worthless. This is a very special probe. As a matter of fact, I'm lucky enough I have two. This one goes from, let's see, where is it? This one says 10 kilohertz. Oops, let me see if I can get that right. See if you can read that. 10 kilohertz to 600 megahertz. The light's just right. And this other one is 20 kilohertz to 1.2 gigahertz. They both calibrate. There's a slight difference between the two, but it actually works quite well. Now, there's also some issues in trying to find manuals for them. I use the Bama Boat Anchor site a lot. That's a marvelous, wonderful site. I really appreciate the people that keep that site running and updating. And I have found schematics for it, but this one is a serial number 1898, and the one that I found was a higher serial number, like the schematic was for this model in 91CA for something like 2400 serial number and above. And they're not quite the same. They're really close, but they're not quite the same. This is easy enough to pull out. You got to remove 6 screws, 4 on the sides and 2 in the back. But all the components in it look original. I know some of you will say that I should change all the capacitors, and you might have a point. But the thing calibrates and works actually quite well. Now, you're not going to get, 0.1 or 0.01% digital accuracy out of it. That's for sure. But the darn thing works, and it's extremely sensitive. It actually goes down to 1 millivolt full scale, and that's a tiny amount of power. Power is E squared over R. So if you do 0.001 squared divided by 50, I don't remember what that number is, but it's extremely sensitive. Now, obviously, there are better ones to have. But if you run across one of these in an estate sale, or something from a silent key ham radio operator, and it has the probes in it, then all I want to show you here is the calibration on it. It's actually fairly easy, but like I was saying, it has some differences, so you got to kind of figure it out a little bit. You could get the schematic for the one with a higher serial number range, but of course you take it apart, you check it out, plug it in, let it warm up for a day or two, or whatever it takes, and then the calibration holes are out here on the side. Now, I labeled them. I just put some labeling on them, and they label them as like pot number 1, 2, 3, 4, 5, 6, 7, 8, and 9, and then there's a couple inside too. We won't go over the whole shebang, but almost the purpose of this video is to show you that if you get the schematic for the and the calibration procedure for the higher ones, it's a little bit different from this one. The difference is pot number 4. Pot number 4 in this one sets the range for the upper ones. These 3 are the same. It's the 1 volt, the 3 volt, and then the 0.3 volt. See, these two seem out of sequence, but that's the way it is. And then this sets the range for these 4 up here, and it actually is it's actually quite nice. These probes are supposed to have the same serial number as the unit. Now, if you get one with probes with the same serial number as the unit, you've probably got quite a nice instrument, assuming that it's in good shape. A lot of times they are, you know, a lot of times they've come out of military labs or schools or whatever. I don't know where they could come from. They come from darn near anywhere. But I have been extremely lucky with a lot of the old stuff I've gotten, especially the General Radio. I don't know, just tons of stuff. I've partied out a lot of instruments. I've probably partied out some I wish I hadn't in my earlier days when I didn't know anything about them. I used to have a BC 610. I sure wish I had that one again. You know, the old World War II Army transmitter. Used a 250 TH in the final, I believe, and modulated with a pair of 100 THs or whatever. Maybe it had 100 TH in the final. Anyway, that's not the point here. The point is these things are restorable. They're actually worth having, and I've documented other instruments like this that later on, a few years later, they quit working altogether, and an attempt to fix them was just not worth it. So I don't know what I'm going to do exactly with this one. Now, of course, a much better instrument than this nowadays to have is if you want an analog meter. Let's move the camera over here a little bit. Got to bump it around a little bit. Trying to keep it really nice and steady. The one to have, in my opinion, is this little HP meter right here. I don't want to get it down because it's not about that. But these little guys right here are that wire's in the way. Always wires in the way. These are the ones to have right here. This 432A power meter. You can get them pretty cheap too. Well, sometimes they're not so cheap. But once again, unless you get a good one of these, unless you get a good head to it, the meter is absolutely worthless. I have two of these heads. I'm really lucky. This one works. This is absolutely an amazing meter. It compares exactly within fractions of a percent to the signal generator I use down here. This guy down here. This fellow right here. They are laboratory grade. You will love them. But anyway, back to this guy right here. I'm not sure I have a whole lot more to show you about it. It's calibration. Oh yeah, I did want to show you this. This was important. These meters, I mean these probes right here, you actually can get an idea if they're worth something. I'm trying to just show the highlights of this, so in case you get one and you say, well, where in the world do I start? Is anything on it worth anything, or anything any good? Well, I found out right here that you could measure this probe and tell if there's something alive about it by just measuring the two diodes in series. And you can use a whole analog meter like this. I got it on R times 10K. And you could put your meter across it, across the two probes. I'm just taking the clips off right now to make it just a little bit easier. So this is sort of a go no go check. If I remember correctly, let's see where it plugs in. This is the positive right here, and this is the negative over here. See there, I get about, not on a 10K scale, that's about 20 something K. If you read it the other way, you're reading the diodes reverse biased, and you get nothing. So that's one place to start. Like if you want to check it to see if it's going to do anything, to make sure your probe is at least intact. It may not be perfect, but at least it should start to work. And both of these probes do exactly the same thing. So that's a diode check of the probe. Let's see if we can prop this thing up, just get a little bit better angle at it. Don't want to crush my. Do not crush my my HP 15C meter there. I don't want to crush my other instrument either, but I'll show you. Let's see. If we come out of the signal generator and we put a signal into it, we'll do it right quick. I've got 300 millivolts coming out right now. and it's on the 300 millivolt scale, and there it is. There's the 3. And you can adjust them. You can adjust all of them. I'll put it over on the 1 volt scale. It measures 300 millivolts right there. You know, we got the the 10 scale and the 3 scale. Everything is either 1 or 3. And all the way down to, let's go down to like 3 millivolts. 3 millivolts. Crank that thing down right there. It takes it a second, and the manual tells you this. If you overload it, it takes it a second to settle down. There it is. It's coming back, and if you look straight on, there's 3 millivolts. We'll go to 1 millivolt. 1 millivolt. So this thing is sensitive. It's going to take it a while to slow down. Let's see, the 1 millivolt would be right there, full scale. So I've actually made it calibrate fairly well on all the scales. Now this one, I don't know if it's going to actually, let's see, this is on the 3. It should come back over here to 1. It may eventually. It looks like it's pretty slow. They tell you it can take as much as a minute for it to really settle down on these, on the 1 millivolt and 3 millivolt, these very high gain scales. It's pretty sensitive up there. And even with no load on it up here on the 1 millivolt scale, it'll sometimes just sort of float around, and they say that's normal. I guess you could short the probe here. I'll put a load on it. I think that'll make it come back a little faster. So I don't know any time. I mean, if you're measuring one millivolt on 50 ohm, this is a 50 ohm device. It's not a 600 ohm device like for audio. E squared over R 0.001 squared 50 divide. See, that's if you could, the camera will focus on that and everything. That's 2 times 10 to the minus 8. So that's 20 nanowatts. So you can measure some really tiny stuff with it. Actually, a meter worth having, in my opinion, if you can get one that hasn't been abused. This is kind of more of a personal comment, I suppose, but from my experience, and experience is worth something. It's not worth everything, but oftentimes when you get instruments like this, it's probably a good idea to not swap out all of the tubes. You may have a bad one in there, but you may not. And the thing could have been working for a long time, and then it's been inactive for decades. And if the capacitors haven't gone bad in it, and they may not have, depending on its environment, just because capacitors are old does not mean that they're bad. I know that there is a mentality that everything that's got an electrolytic in it or a bumblebee capacitor, all that kind of stuff, is to be swapped out immediately and cast away as far as possible. That may not be a good idea. And it is probably a very good chance it's a bad idea to just swap all the tubes out. The tubes that are in it actually may still be matched and of better quality than you realize, because a lot of these instruments, and I know this is especially true of the Tektronix instruments that I'm familiar with, the tubes, just like a lot of the components, are hand picked, and they are meant to be in the socket that they're in. And repairing and calibrating, especially calibrating these instruments by just swapping in other tubes, may be well over our head and beyond our ability and beyond the instruments that we have to repair and calibrate them. Anyway, there it is. That's the old Boonton model 91CA meter, ready to be used again for RF measurements. I don't know how much longer it'll work, but it looks like to me that probably the only thing that's going to go bad in it eventually, certainly, it would be the capacitors. and you have to spray them and what have you. But I like to document this old equipment because it's vanishing by the day. People are looking at it and going, ooh, I can't fix that. I don't have the tubes, I don't have the time, I don't have the test equipment, and all that's very understandable. And I can buy something that'll work better than that, you know, for $29.95. And when it quits working, I just throw it in the trash can. And all that's true. But there's still a few people out there that like these old instruments. But anyway, I know this won't be my most favorite video, but I like to document these things before they vanish. So thanks for watching.